Welcome to Choosing the Right Data Store, an overview of Azure data platform changes or choices. I'm Joey D'Antoni, and I'm not going to be talking about technical sales. That was our sales rep who has a little bit of an illness and is unable to present today. So this was kind of our replacement topic. We're going to talk about everything that's available to you in Azure kind of to run databases. And I'll touch on a bunch of services as quickly as we can. If you have any questions, ask them quickly while I'm talking. Just raise your hand and I'll acknowledge. Or if you're online, just put them in. I'll do my best to answer. It's a 20-minute session. I'm Joey D'Antoni. I'm Principal Consultant at Denny Cherry & Associates Consulting. I'm a Microsoft Data Platform MVP. I have been since 2014. I'm also a VMware vExpert. I've been working on Azure pretty much since Azure started, so I've seen a lot of this stuff evolve over time. You can find me on Twitter at jdanton. I also write a column at Redmond Mag called Joey on SQL and some other Azure stuff there. This is an old slide, but I keep it because I like to show all the services that are available, and guess what? There's like 3 times as many now. This was all the services that weren't available in Azure in about 2016. And we see in our data, we see some of the older names for some of these services like SQL Database, SQL Data Warehouse, which is Synapse Analytics. You'll note the distinct lack of managed instance, Document DB, which is now Cosmos DB. But there are a number of other services, data lakes, all these offerings, and this gets really confusing for a lot of users of the cloud. So in this session, in 20 minutes, what we're going to do is kind of distill down the main choices, what they're good for, what they're not good for, because it turns out sometimes there are sales representatives who are disreputable and will try to sell your managers on solutions that might not fit your workload. For example, I had a sales rep try to tell my customer, who, by the way, was the second customer to go live on SQL Server 2016 in August of 2015, that their data warehouse wasn't going to scale in SQL Server and they needed to move their 50 terabyte data warehouse to Cosmos DB. Bad idea. Those things happen. Bosses are stupid. You know better. So I always like to give a cloud overview. You may have seen this slide a million times. If you haven't, we'll walk through it. So traditional on-premise is you own everything. The easiest way to think of this is if you had to patch something like that major Intel patch a few years ago. If you have everything on-prem, you have to patch the BIOS of the server all the way up to the mouse on your desk. In infrastructure as a service, Microsoft, in this case, would patch the BIOS on the server. They would also patch the virtualization engine. You're still responsible for the OS layer and the applications. Platform as a service, you wouldn't patch anything. It just gets patched for you. And then software as a service, which is really out of scope for this talk. We're not really going to be talking about anything software as a service. One of the key things I want to mention, and this is really specific to SQL Database versus SQL Managed Instance, Azure SQL Database is decidedly platform as a service. I really like the service. MI is somewhere of a hybrid between infrastructure as a service and platform as a service. There's a lot more networking and infrastructure components that you have to worry about managing, and we'll talk about that in a little more detail as we talk about those platforms. But one thing that you want to understand is not all platform as a service offerings are the same. Generally speaking, when we talk about platform as a service offerings, that means 3 major things are done for you. You don't have to worry about patching an operating system and, say, binaries for your database software. You also don't typically have to worry about backups. Those are handled by the cloud provider. Although you always want to ask the question about backups, and if I have time, I'll tell a story at the end about that. Because different service offerings have different SLAs and different data loss protections, and it's really important to understand what that means for your application. And then finally, they provide high availability. So when you deploy a platform as a service offering, at least on Azure or AWS, those services are inherently highly available, so you don't have to worry about things like clustering. The key asterisk on that high availability part is almost all those services are only designed to be highly available within a region. So if you want to be able to sustain a regional failure, you need to worry about DR, and typically you're going to pay extra for DR. These aren't universal tenets, but they're mostly true across probably 90% of the platform as a service offerings and everything we're going to talk about here today. So those are kind of the guidelines: from high availability, patching, and backups. Microsoft likes to make up marketing terms. For example, there are like 6 different offerings that have the words Azure, SQL, and Analytics in the name, and they all do different things with possibly a couple of different adjectives. So Microsoft has a term, and it's a marketing term that I know MVPs know because we're data platform MVPs now instead of SQL Server MVPs, but it's called the Azure Data Platform. And this represents a number of facets. So if we look from the left, we have database and big data, which I don't even think anybody uses the term big data anymore, but marketing. And this includes SQL Database, SQL MI, Cosmos DB, Synapse Analytics, which is kind of built on top of Azure Data Lake. Data Lake's really not a data service in and of itself. HD Insight, which has mostly fallen out of favor. And then, of course, SQL Server on-prem or box or whatever you want to call it. We also have information management solutions like Data Factory, I didn't update the slide, Purview, which was Data Catalog, and Event Hubs. We have the machine learning stack, and of course we have Power BI and some other intelligence platforms. So that's all the stuff we're encompassing in this talk. We also have a term, another made-up marketing term that nobody knows except MVPs and marketing people at Microsoft, called Azure SQL. And usually when you say Azure SQL, people are like, you mean the platform as a service thing? And you're like, actually, no, it includes SQL Server too, because it's a made-up marketing term. But this is the marketing term you might hear from Microsoft. This includes SQL Server on Azure virtual machines. Technically, it also includes SQL Server running other places, because once again, bad at naming things. And this gives you complete control of the OS and SQL Server and gives you some more flexibility that you may not get in the platform as a service offerings. Managed instance is typically going to be designed, and we'll go into specifics of this in a few slides, but it's typically designed when you're moving an on-prem SQL Server and you want to migrate it into a PaaS offering. That's the goal of managed instance. And for the most part, it meets that goal. The big limitation that SQL Database has is you can't easily do cross-database queries. So that means for a lot of traditional applications that were designed around on-premises SQL Server, it's just simply not going to work. Azure SQL Database is probably my favorite of these platform as a service offerings, but it is really best for newly developed applications that are going to live in the cloud full time, because no cross-database queries easily, but you do get a lot of benefits that we'll talk about in a little while. So when we talk about SQL Server on Azure VMs, why do we want to have these? The most common reason for this is the initial migration. Nobody wants to migrate into the cloud and switch their database platform at the same time. Or they're doing a lift and shift migration where all the VMs are getting migrated from on-prem to the cloud. You can argue as to whether or not that's the best approach, but in my DBA hat, I like to make kind of one major change at a time. And for the most part, migrating from an on-prem VM to an Azure VM isn't that hugely different, other than your storage configuration. And from what I observed, most of my customers don't really change the storage configuration like they should anyway. But you do have more control. So you have SQL Server and OS versions. You control the SQL and the operating system version. So if you have a software vendor that says you need to stay on SQL Server 2017, you have that choice. You also have file stream, distributed transaction coordinator, and the simple recovery model. None of those are available in any of the platform as a service offerings. You also have SQL Server analysis services, reporting services, and integration services. And you also have free extended security updates for SQL Server 2012 now. I need to update this slide. So when do you absolutely have to run on a VM? There are a few scenarios, and the main one is that you have to run SQL Server something services alongside of the database engine, and you don't want to have to run 2 boxes, or you don't want to pay for Data Factory alongside of managed instance. That's a fairly common scenario. Also, you need to run on an older version of SQL or Windows because your software vendors are terrible. You still want to have the option to migrate out of the cloud. This slightly changes with SQL 22 and MI. But if you have a VM, you have much easier migration paths out of the cloud than you do a managed service. It's kind of as simple as that. Finally, price and performance work better for the workload. We don't have enough time to go into great detail on this. If you need a lot of storage and high-performing storage, and you need SQL instance features, a VM is simply going to be more cost-effective than managed instance. So now we're going to dive into the platform as a service offerings. General purpose, both managed instance and SQL database support these two tiers. And I'm going to try to distill this as quickly as we can. You have general purpose, business critical. These tiers apply to both of those offerings. General purpose use remote storage. The big caveat to this is when you use this in managed instance, your storage performance is associated with the size of your database at creation. If you ever look in Azure Storage to see how many IOPS are associated with a particular size of disk, that's the way MI works. So you want to make your you typically want to make your databases bigger than they need to be to get the I/O performance you need. This supports up to 16 terabytes of data. And for high availability, it uses a functionality that's similar to failover cluster instances where you have effectively one VM and then 3 copies of your data. Business critical, on the other hand, uses direct attached flash storage that's stored in the VM. This is good and it's bad. You get better storage performance instantly, but you also have to pay for cores to get more storage. So if you need 16 terabytes of storage in business critical, you're looking at like $27,000 a month. The availability model is also AG instead of FCI, so failovers are faster, and you can read secondaries. Azure SQL Database, not managed instance, offers a service called Hyperscale. This supports up to 100 terabytes of data. And gives us a really nice horizontal scaling model. So one of the limitations of Azure SQL Database used to be the long-term size, because when the service started, the biggest your database could be was like 3 gigabytes, I think. Now it can be 100 terabytes plus. So Hyperscale kind of eliminates that concern. We also have a serverless offering on SQL Database. I hate the name serverless here, because guess what? You still connect to a server. This is an auto scale and auto pause feature. It does cost more per second than Azure SQL Database does. However, if you're pausing, then it can be cheaper. And in a lot of dev environments, it can be a lot cheaper. I'm going to talk about cost later today in another session, so feel free to stop by. The big caveat to serverless is if your database has to run 24/7, or you have some service like change data capture, or any other kind of server replication that runs 24/7, you don't want serverless to be on because it does cost more per moment. So SQL MI or SQL DB. DB gives us a few more deployment options. MI is really good, and what I will tell you is that if your workload fits in the middle of the MI stack, like you're not pushing the envelope in terms of compute or storage, it's a really good service. Where you start pushing the envelope of size, the costing can get kind of ineffective. And just to narrow this down to features that MI supports that Azure SQL DB does not. MI supports CLR, Common Language Runtime. The hardware is more isolated, so they can do that. You can do cross-database queries. That's the big one. It does support sort of log shipping for migration. There's a service called LRS that lets you do something like that. It also supports migrating using availability groups. Service broker and distributed transaction. You can also restore from a SQL Server backup, just not point in time directly. And there's database mail and SQL agent. So managed instance is much more practical. It's just in a tighter box because you don't have that hyperscale option. So as your data volume and performance needs grow, you can get capped out. And that's kind of a fundamental problem with that service right now. Okay, we're going fast because this is a long session. But Synapse Analytics. This used to be known as Azure SQL Data Warehouse. It's a massively parallel processing system. That means there are a lot of nodes behind it. This works really fantastic. It's also really pricey. And I'm mainly focused on dedicated capacity and not serverless, which is kind of its own thing. But this is something I've run into many Microsoft sales representatives trying to sell, including for OLTP workloads. high frequency read and writes, large number of singleton selects, high volumes of single row inserts. These are not good patterns because Synapse's key architecture components are built around highly compressed column store indexes like we've had in SQL Server since 2012. It's really fantastic for a data warehouse and big data warehouses. And I just used the term big data, and I didn't mean to. But not good for row-by-row processing. What is it good for? Storing large volumes of data. If you have a multi-terabyte data warehouse, you should be looking at Synapse Analytics. If you have a data warehouse that's like a terabyte uncompressed, and if you use column store, you can probably put it in a 400 gig. Maybe you should think about trying that with SQL Database and seeing how it works, because Synapse Analytics does cost a lot. You can pause Synapse Analytics, so a lot of customers will build a Power BI model off Synapse Analytics and use the Power BI model to manage cost. You can do query analysis across large data sets. Data ingest is exceptionally fast at scale, but like I mentioned, this is also one of the more expensive services, and I think it might possibly have the highest. There's a DWU 30,000, and it costs over $300,000 a month for that SKU, and it's very expensive. So Synapse is very good, but make sure you have the right workload for it, and then you're really seeing the benefits from it. Finally, we're going to talk about Cosmos DB. I really like Cosmos DB. It's a really cool service. Unfortunately, it has a really horrible pricing model that is somewhere between a couple of $100 or a couple £100 and all of your money per month, depending on usage. So this is a fully managed, globally distributed database. We have a bunch of different database offerings in this. So it supports PostgreSQL, SQL. There's a SQL API, which is what's formerly known as DocumentDB. Cassandra, which is a column family database. MongoDB, which is another document database. The Table API, which is an original Azure construct that's a key value store. Gremlin, which is a graph database. And it also supports Node and JavaScript. So we have all these different models. We can have them all on the same database. It's all pretty low latency. It's all built around local storage. You can have global redundancy. And the thing that the managers really like, you can have writes in two places with the same database. But you pay actually more than 2 times as much for that. And just like any system where you have writes in multiple places, if you have high volume on that and you have a lot of conflicts, your database is going to spend a lot of time doing conflict resolution. There is no magic, it's just computer science. But really cool service. You can configure the consistency model, which is something a lot of devs like, so you can set up eventual consistency to kind of optimize for writes. And there are really few really good use cases. And I took these from Microsoft Docs because I heard too many sales reps say too many bad things about this. Anything that's got super fast ingest, like Internet of Things and telematics data, where you're just ingesting very, very quickly. Retail and marketing data, so to store catalog data that you want to be at low latency, event sourcing and order processing pipelines. Gaming use cases, so storing state data for games is a really efficient database for that. And then finally, web and mobile applications, where you want to put a lot of database endpoints close to your users so that they have kind of good performance and good experiences. It's a really good use case. This is not something I would typically recommend for super high volume databases, but maybe super high throughput, lower volume databases. So finally, to summarize what we covered in 19 minutes and 6 seconds so far, you need to understand what the public cloud is. Remember those key tenets of platform as a service offerings: backup, high availability, and patching. And you always want to ask about what backup is. If I have 30 seconds, we'll finish this. Know your platform options. So know what your choices are in your specific area and know the specifics. Things change all the time, so it's important to stay on top of docs. Understand what workload fits in where. Don't let your manager get bamboozled. Big data warehouses go in Synapse. You can probably fit a small data warehouse in Azure SQL database. And one thing, if you're developing custom applications, your apps may use multiple data stores. And I have 12 seconds left, and the story I wanted to tell about backups was that Rackspace had a big outage of their email system in December because they got breached, and I got to interview their CTO, and he told me we didn't need backups, we had a cluster. The end. Any questions? I can take them after or just come up.